Greetings, Chem 1 students. This is Mr. Braun. We're going to talk today about the pre-lab for the boiling point elevation lab. This is a colligative property in which we're going to be adding sodium chloride to distilled water to increase the boiling point. Okay? You're going to need balances, computers, direct temperature or stainless steel temperature probes, and the equipment in your drawer. You're going to need to know what lab to do, so make a note of this, folks. Make a note of this right now, that you are going to be using the physical science with vernier, and you will open lab 2, which is a boiling point lab. So once again, physical science with vernier, and the lab will be boiling point. Now there's a couple of pre-lab activities that you're going to have to do, all right? It says right here that we need to calculate the theoretical boiling points for a 1 mol and a 4 mol solution of sodium chloride. Record these answers on the back data table. So if I pull to the back side of this paper, right here, you're going to see theoretical boiling point. So right here, you will have two numbers to calculate your theoretical boiling point. Now remember, when calculating the theoretical boiling point, we are going to use the equation that the change in the temperature of the boiling point is equal to Van't Hoff's factor times the boiling point constant times the molality. So you will need to use that equation to calculate both of the theoretical boiling points. If you forget what that equation, look back into the notes that you took previously. It is in there. Now, a certain thing also here that I noticed on this lab, it says absolute air, relative air. What I would like for you to do with that relative air is just cross that out, and instead of that, I want you to do percent air. So instead of the relative air right there, cross out the word relative and put percent. So we'll be calculating the percent air. Let's go back to the second pre-lab thing that you need to do. You need to determine how to prepare your 1 mol sodium chloride solution using 200 milliliters of distilled water and your 4 mol sodium chloride solution using 200 milliliters of distilled water. Well, let's go through a couple of things here. I'm going to help you out here with the 1 mol solution. If you remember, molality is equal to moles of the solute divided by kilograms of the solution. Well, my problem here is that I have and I need milliliters, not kilograms. So I have to have some way to determine milliliters from kilograms. Well, what that way is called the density. We are using distilled water as our solvent, okay? Distilled water as our solvent. Well, what do you know about water? Water has a density of 1 gram per milliliter. Okay, let me do that again. Okay, 1.0 grams per milliliter. So if I have 200 milliliters, and I know the density is 1, I know the density is 1 gram per milliliter. How many grams do I have? Yes, ladies and gentlemen, I am going to have 200 grams. So when I am doing this equation, my molality for this particular one is 1.00 molal. My kilograms is going to be my number over here, my 200, 1, 2, 3, converted to kilograms. So it's going to be 0.200 kgs. Now, once I work this equation, I can solve for my number of moles. Once I've solved for my number of moles of solute, I need to convert that into grams. That's a flux capacitor move. Why do I need to convert that into grams? We do not have any scales that will read moles in this lab. Okay? And what you'll be doing, you'll have to do the calculation for the 1 molal, then you'll do the calculation for the 4 molal. So what you will do when you are making your solution is you'll take this number of grams that you just calculated here and add it to 200 milliliters of water, because that's the same as 200 grams of water. So take that amount of grams, add that to 200 milliliters of water, and you will have your 1.00 molal solution. After you create that solution, and it doesn't really say this, okay, I got to erase my stuff here on the board. It doesn't really say this anywhere. You have to make 200 milliliters of this solution, but you do not need to put all 200 milliliters in your beaker to boil. So you're going to take a beaker, you're going to use our typical boiling apparatus where you have a wire gauze and you have double O-rings. What I mean by that is an O-ring on top to hold the beaker in place to make it more secure, and an O-ring to hold the wire gauze. So you're going to boil that. You do not need to, once again, you do not need to use all 200 milliliters. You could say use 100 milliliters. It is not going to change the boiling point, okay? Once you get the experimental boiling point from the flat line of your graph, you write it in here and you can finish your calculations. Once again, this has been Mr. Braun talking about the boiling point elevation lab. Ladies and gentlemen, let's investigate.